Good morning, afternoon, evening, everyone. My name is Paul Edward, and I have over 12 years of experience in enterprise software development. I love the open source community. I contribute to the open source community. I love writing, I speak, I build, and most importantly, I'm a boxing advocate. I will be talking to you about a topic that is very dear to me, the race you don't want to win. I've been fortunate to work on systems that undo sensitive transactions, which means security is always a top priority. Today, I will share a story about a breach we faced, a flaw very subtle yet devastating that shook our system and our confidence. This is the race you don't want to win. So let's dive in. So imagine two kids running to grab a cookie from a jar. The jar is supposed to hold just one cookie, but if the kids grab at this exact same time, the jar might magically let both of them win. That is a race condition. Two processes competing to access the same resources, and most of the time the system gets very confused. So in software development, this happens when two processes try to access or modify the same database record at the same time. Imagine your system is updating a user wallet balance, and two withdrawal requests hit the database simultaneously, and there are no checks in place. In that case, the database might end up processing both of them, even though there was only enough money for one. So it is like your code is running just too fast for its own good. And here is the kicker. It doesn't matter what programming language you're using, Java, Python, even SQL database aren't immune. Race condition doesn't discriminate. They mess up any system, and that is if you're not careful. So race condition has cost the world a lot of money. In companies like Knight Capital has lost over $440 million. Even this year, GT Bank has had the same issue according to the news report online. And they were I think they had 2 weeks of transaction failures. And so these smallest oversights, most of the time, I think all the time, they have very catastrophic consequence. So that is why we're talking about it. So here's what happened in our system. Our app processes wallet transaction. Let's say a user has $1,000 in their wallet. Then a clever attacker discovered they could send two withdrawal requests at the exact same time. The system, thinking it is handling things one by one, approved both requests. The same $1,000 was withdrawn twice. So it was like the system was just too polite to say, hey, wait your turn. Now, multiply this by hundreds of transactions and you are going to be staring at a massive loss. A financial loss of over 70 million and a loss of sleepless nights. How did we tackle this? We immediately launched an investigation. Step one was to identify the breach entry points. We combed through the logs, replicated that issue in a controlled environment. We used tools like log analyzers, and debugging frameworks were our best friend at that point in time. It wasn't just about fixing the problem. We needed to understand fully what really happened to be able to prevent future exploits. And I would really advise you to do so as well. So what are the countermeasures that we also did? Our first move was damage control. And we disabled the affected feature first of all and implemented a temporary fix just to stop that exploit. And long term, we redesigned the transaction flow to be able to handle. We also added some very stricter monitoring and anomaly detection, ensuring that subtle irregularities will trigger an alert. And we also implemented an accounting feature, the principle of double entry, just to make sure that for every credit, there is a debit. For every debit, there's an equivalent credit as well. The preventive measure that we took, we made sure we test for edge cases. This weird scenario where your code might break, you have to always test for edge cases and probably under a controlled environment, simulate a very high traffic stress test your application to see if it holds up. You have to always think like an attacker. Yeah. If you were trying to break your system, how will you do it? Ask yourself that question. And review your code with concurrency in mind. Ask yourself, what happens if two people click the same button at the same time? Secure coding is all about asking the right question. Regularly test for vulnerabilities, anticipate edge cases, test concurrency under high loads as well. So I'm just going to be walking you through a very live demo to explain to you in real time how race condition works. So I spinned up a PHP application. This is a wallet controller as a withdraw method, and this withdraw method is taking into payload the user ID and amount. The user ID to be able to identify the wallet that we intend to make a withdrawal from. And here is where we're trying to get the withdrawal, the wallet that belongs to that user. And if that wallet is not found, we immediately throw an error that the wallet cannot be found. And if the wallet is found, we check if there's sufficient, if the balance is sufficient enough to be able to make a withdrawal. If there's no enough fund, we trigger insufficient balance straight up. This code looks very cool because you're doing all the right checks. All the things are rightly done here. And immediately after that, we deduct the money from the user's wallet balance and immediately update our database record. And we also notify the user that the withdrawal is successful as well. And if anything goes wrong, we throw an error telling the user that probably, okay, something went wrong. If you're looking at this code where I'm doing all the right checks in place, everything is done in the way that is expected to be done. And I'm sure if you try this, you probably throw a request at this will work very smoothly. The right amount of money that you're throwing at it is going to be deducted accordingly. If we are going to be attacking this probably with race condition in mind, let's see what is going to happen. So here I spinned up a Python code base, and I'm making a call to that endpoint. And we have a user ID of 1, and because I think I need to show you what is happening in the database here. So let's look at the wallet table. If you look at this, we have a user ID of 1 and the wallet balance is 0. So I think let's make this 600. Let's save this quickly. So here is the Python request, and just a very basic Python script that sends multiple concurrent requests to this endpoint. And I think we're just going to be sending 10 simultaneous requests to this endpoint instead of 1. I think let me try to just probably simulate just one request and see. Let's see what happens. We're going to be deducting 100 from the 600 box we have in our database. And if I'm calling this, probably running this Python scripts, what do we get? As you can see, your new wallet balance is 500 now. 500. And if we are to refresh this, you will see that I think balance has been updated to 500. Everything works very smoothly. So what about if we decide to make these 10 simultaneous requests? Like we are trying to call that endpoint 10 times, and those 10 that we're trying to deduct 100 bucks. We should not be able to deduct this because 100 multiplied by 10, I think that will give us 1,000, and we just have 500 bucks in our wallet balance. So let's see what happens. So I'm going to be initiating this, and if you can see, I was able to make this call 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's still telling me here that I have 100 bucks as my balance. I was able to make a withdrawal of 1,000 bucks, 1,000 bucks. And telling me here that if I'm to refresh this, we have a balance of 100 bucks. What does this mean? I've cheated the system. Yeah. So, just in case you have this, I will advise you to run this script against probably your code base and see, and probably the results might be very shocking to you. So one of the lessons that we learned from this is this. I'm coming back to explain how you'll be able to fix things like this. is you need to know that small flaws have very big consequences. A single bug almost brought down our system. And prevention is better than cure. Test, proactively test and test repeatedly. Monitoring could have also caught this earlier, but I don't think we implemented all of this at the earlier stage. And also, security is a team sport. It's a collective effort. Developers, testers, even users have roles to play in keeping systems safe. But the real takeaway here is this: treat every bug like it could be your next big breach. I think let me repeat this again. Treat every bug like it could be the next big breach. Because sometimes it will be. Yes, it could be sometimes. So I will really emphasize on also secure design and testing at every stage as well. So before I would go back to the conclusion, let me quickly go back to the live demonstration and okay, how did we fix this? So one of the things that we did, let me go back here, is one of the ways to be able to prevent race condition is to use things like we call distributed locks to be able to control resource access. Use transaction logs and rollback mechanism, like probably your DB transactions, to make sure that when probably there is a breach at any point or there is a failure at any point, it can roll back the previous record that it has entered. And like I said earlier, introduce rigorous testing and probably in a controlled environment, simulate high concurrent scenarios to be able to show that your code is running very smoothly. So let's go back to the code base, and I think that will add more light to what I've just said, and that is it. So now we have 100 bucks. I think I'm going to make this 500 now, and let's save this. So I implemented another method here where we call this the withdraw fix. So we are taking in the same payload, the user ID and the amount. But what did we do here? We, just like I mentioned in my previous on the slide, that you should use transaction logs and rollback mechanism. And that was what we did here. Laravel has a feature like this. I think this is for Laravel. Other frameworks other language has their own method in also making sure for you to be able to do your transaction log and your rollback mechanism as well. But this is strictly for Laravel. So we started the transaction here that anything between these transactions, when there's an issue here, it should immediately roll back anything that it has done previously. So sorry, I was not showing you the code base. So here we started the transaction. Yeah, I think, like I said, this is strictly for Laravel. So now I think let me close this so we can have a full screen. And another thing we did while we were checking for the user that owns the wallet, we do what we call log for updates. So we're saying that pending when this query is being run on the database, lock that row for any further updates till I'm done checking what I need to do here. Till when this query is successful, lock this for further updates. So, and I think this is one of the first places we actually started solving the issue of the race condition. And if the wallet is not found, you need to do the same thing. If the wallet is not found, notify the user the wallet is not found. And here we do what we check if the database if you have enough funds in your DB, and we do a rollback here. Just when your wallet balance is less than the amounts, we do that. And if not, just in case any edit has been made to the database within these points, so we want it to be rolled back. So here, at this point, then we make the wallet deduction on the database and we commit the transaction. And if everything is successful, we return that successful message to the user. And in the case of any error, we can also roll back here. I think I can also take this out, the roll back here, and just probably add one. This is just to be able to prove a point on how we can solve this. as well. So now we are going to call this second endpoint. And I think what I call this is, let me say withdraw fixed. And don't forget, we just have $500 in our wallet balance. So I'm going to call this again. I'm going to run this again. So we're going to still simulate 10 concurrent requests and let's see what happens. So I think 10 concurrent requests, that will still be 1,000. I should not be able to withdraw more than 500 because that is what I have in my wallet balance. So we'll try it again. Good. Now, as you can see, something went wrong. We started here. Something went wrong. Yeah, our first balance, we made the first $100 withdrawal request, 400, 300, 200, 100, 0, and it immediately started saying insufficient balance, as you can see. So we could not make that same withdrawal of $1,000 like we did earlier. So, and if we are to check the database record, I think it should be 0 right now. So we've prevented the issue of race condition. I really hope this is clear. I believe it's clear. So let's go back to the conclusion and So security isn't a sprint, it's a marathon. It is not just a checkbox, it is a mindset. We need to have security as a mindset. The race you don't want to win is the race to fix your system after an exploit. So let's stay vigilant, test everything, and remember, it is better to prevent the fire than to put it out. Thank you.